Good evening, everyone. Welcome to another Planetarium live stream. Thanks for tuning in, everybody who's watching live today on August 7th, 2023 at 6 p.m. Central. This is a live stream, so be sure to shout out in the comments where you're watching from. Let us know. And if you have any questions throughout tonight's stream, let us know as well. For those of you who don't know, my name is Patrick Hess. I'm the Planetarium Manager at Union Station. And I've been live streaming every month for a few years now, bringing you the latest highlights of what's up in both our night sky and in the news world of space exploration and astronomy. So we're going to be exploring that today, looking at our night sky and seeing what's up in the summer skies, as well as what's been going on around the world of astronomy over the past couple months. We missed last month's live stream. I do apologize to anybody who was hoping to check that out, but we are going to be coming back and catching up with the past few months. For those of you who don't know, or you're our first-time watcher, this is our 95th live stream. We've been live streaming every month for a few years, and in 2020 we live streamed every week, where we covered a bunch of different topics and did deep dives into a bunch of different areas of astronomy. We do have a YouTube channel, youtube.com/kcplanetarium. Subscribe to us there if you'd like. We've got curated playlists of all of our past shows if you want to check any of those out. Over 80 hours of content. Yeah, we have 95 of those shows, which is pretty incredible. And I wanted to start off tonight actually talking about that because we are getting to almost 100 live streams. I want to make a very important announcement. And that is that we're going to be counting down to our 100th show, which will be our grand finale. So that is going to be our final regular live stream program. We will be continuing after that with any special events, like, for example, maybe a mission to the moon, which hopefully will be happening next year. But we do only have 5 more shows as part of our regular live stream schedule. So if you don't want to miss those, we've got a basic outline of what is going to be going on. And I'll move out of the way here. Next month's stream, we're going to be bringing back a live stream that I did back in summer of 2020, where we made a comet in our living room with ingredients you can get from a grocery store. So we're going to do that again. I'll even have a lovely assistant this time, my fiance Emily, and we'll have just a fun live stream in our living room. So it'll be a change of scenery, and we will create a comet, teach you how to make a comet. If you'd like to do that at home, we can even share the ingredients ahead of time if you want to do it along with us. And we'll talk, of course, all about the science of comets as well. In October, we'll be bringing back another fan favorite live stream topic. We'll be looking at Hollywood astronomy. There are a lot of different movies that have come out in the past couple years, and we've had a lot of requests for both movies and books and TV shows. So I'm going to be kind of wrapping those all into one show where we'll look at fantastic worlds of fiction and how they relate to astronomy and space exploration. We'll look at the science of science fiction. In November, we're going to do a special vacation variety show, which I don't want to spoil too much. But if you were watching our live streams back in 2020, then you might get a hint about what that'll be, but I won't spoil it. And then our second to last live stream, we're going to try something fun next year in February. We are going to plan a live in-person live stream. So we're going to invite everyone out to the planetarium. And we don't know what we're going to be doing yet, but we'll have something exciting and interactive to do where we will broadcast our live stream live, and we can have our watchers join us for that as well. So stay tuned for details. If you're watching on the Union Station Facebook page, after the stream is over, head over to the Planetarium Facebook page. That's facebook.com/kcplanetarium. Subscribe to us there so you don't miss all the updates, but stay tuned for details. We will have a live stream in person. We'd love to have everyone there. And then in March, celebrating our 4th anniversary of doing these live streams, we will have our grand finale, and we will be talking about what we'll be doing on that show in the future. So again, that is our countdown to our finale for these live streams. It's been an incredible journey, and to everyone who has been a long-time watcher, including people already in the comments, such as Tammy, who says hello from Iowa. Thanks for watching, Tammy, as well as Jerry, who's saying good to see you again. Both Tammy and Jerry are some of our longest time watchers. And Jerry, I know you're sad that the regular live streams will be ending, but we want to end on a high note, and 100 episodes is a pretty good milestone to hit. We are sitting at about 344,000 views, so I hope to break 350,000 before the end before it's all said and done. So the next live stream will be our 96th stream, and that we are targeting for Friday, actually September 8th. It's a Friday because that Monday will be Labor Day, so a lot of people are going to be busy enjoying the end of summer then. Also, that week, actually 2 weeks in September, Science City and the Planetarium will be closed to the public. Every year we close for a couple weeks for maintenance and training. It's a regularly scheduled closing period during a slow time of year. So in the middle of that, on that Friday, we'll be doing our Create a Comet live stream. So mark your calendars and tune into that. We'll be releasing more details about that soon. So thank you to everyone who has supported us for 94 shows. And we're going to kick off our 95th show now. I just want to briefly mention that the Planetarium is open to the public. Right now, we are open 7 days a week for our summer schedule. That is through Labor Day. And we've got some of our fan favorite shows like Destination Solar System and our live shows, Sky Station Live, our seasonal star tour. So come check that out. Tickets are only $8. And if you're a Union Station member, your first visit's free. And one more announcement. We are bringing back our evening laser shows this fall. We have an exciting slate of shows scheduled. Details about that should be releasing soon as they're programmed and tickets are available for sale. But we've got a lot of awesome laser concerts coming up this year, or for the rest of this year. So check those out. Tickets will be available soon, so you'll not want to miss that. Again, be sure to like our Facebook page at facebook.com/KCPlanetarium for those details, and we'll also post on the Union Station page. Don't forget, this is a live stream, so anybody who's still watching, let us know what you're doing or where you're watching from, and if you have any questions during tonight's show, be sure to let me know. But we're going to jump into our first segment of the show, our first What's Up segment, which will be a summer star tour. We're going to look at what's up in our summer skies for the latter half of the summertime now. We've got Lauren in the comment section saying hi from New Smyrna Beach. Thanks for watching tonight. I've done 94 of these streams so far, and every time I'm so formal whenever I announce people I know. But I don't think she'll mind me shouting out, that is my mom. So thanks for watching tonight, Mom. And let's jump into our seasonal star tour. So we're going to pull up our trusty handy dandy flat planetarium software, Stellarium, if you'd like to download that. We've posted links to that in the past. But we're going to jump in here. Keep the comments coming. I'll check back in just a moment, but we're going to jump into our star tour for now. Now we're looking at our view of the Kansas City skyline. We've got Union Station there, and we are actually on the lawn of the Liberty Memorial at the World War I Museum and Memorial. This is our current sky, and the sun is still up in the sky right now, although it is starting to set as we are nearing the end of summertime. The days are getting shorter, and the sun will be setting sooner. But of course, the sun is a star, but during this star tour, we want to look at other stars besides the sun. So I'm going to hit the fast forward button here, and we're going to speed up time to get that sun to go below the horizon and bring out the nighttime stars. And about an hour or so after the sun is fully set, twilight will be gone and our night sky will appear. So we'll spend our star tour at about 10:30 p.m., a little bit past sunset, so we can get a nice clear night sky. A lot of comments coming in. I'll check in real quick here. We've got Dwayne saying hello from Topeka. Thanks for watching tonight, Dwayne. Kim saying good evening from North Kansas City. Thanks for watching tonight, Kim. We've got Sharon saying hello from Colorado. Awesome. It's great to hear from you, Sharon. I'm glad you're watching tonight's stream. Hope you enjoy the show. James and Donna are tuning in as well, saying hello to my mom. Thanks, James and Donna. And we've got Eric, who is my dad, saying hello from Lenexa. There you go. The whole gang is here. Oh, and Emily is saying hello from our kitchen. My lovely fiance just got home, it sounds like. So welcome home, Emily. Hope you had a good day. Love you too. All right, so let's jump into our star tour. So we're looking at our night sky tonight, facing north, where Union Station is on the horizon. And we always like to start with some familiar star patterns like the dippers. That's the Big Dipper and the Little Dipper. I've got the Big Dipper here. These 7 bright stars are always visible in the northern sky in Kansas City. They are circumpolar, so throughout the year they will always be up, even as the night sky changes and the seasons change. And then the Little Dipper is nearby. Its stars are a bit dimmer. There, of course, is a nifty trick to use to find the Little Dipper. Take these 2 stars at the end of the spoon in the Big Dipper and then draw an imaginary line through the stars across the sky. It'll point at this star right here at the end of the handle of the Little Dipper. Now, that star is a very famous star. Its name is Polaris. It's the pole star, the North Star as well. It's also nicknamed. And the North Star is special because it is the only star that always points north. And we've discussed this in the past, but essentially as the Earth rotates around its axis, the stars above you will appear to move throughout the night, but the North Star, Polaris, is the only star that does not move. We're actually going to move right along because I wanted to highlight a group of constellations over in the northeast. And it starts with this constellation here, a little W-shaped constellation. This little zigzag's name is Cassiopeia. And let's, there we go. Ooh, nope. I don't want to do that. I want to do, oh, I thought I had the, nope. There we go. I want to do the lines. C, that's what it is. All right, keyboard shortcuts. They get you every time. This constellation is Cassiopeia. There's another constellation related to Cassiopeia. It's above Cassiopeia right now. It looks kind of like a sideways house-shaped constellation right over here. This one's name is Cepheus. In mythology, Cepheus and Cassiopeia were the king and queen of an ancient African nation. Now, as you can see in this picture here, Cassiopeia was a little bit obsessed with herself. She was very vain, and she liked to brag about how beautiful she was. And one day she actually bragged that she was more beautiful than the daughters of Poseidon, the god of the sea. And when Poseidon heard about this, he punished Cassiopeia for her arrogance by cursing their land with years of flooding, which washed away many of their crops and sent their kingdom into a terrible famine. Cepheus and Cassiopeia tried to appease the god Poseidon by sacrificing their own daughter Andromeda to the sea god. And Andromeda is a constellation nearby her parents. She's sort of a fall constellation, but she's starting to rise right now, so we can see her. She almost looks like sort of a banana peel on the northeastern horizon. Andromeda was rescued by a hero named Perseus, which is a constellation that's starting to rise over here. But really what I wanted to discuss about, or wanted to point out about Andromeda is a deep space object hiding inside of Andromeda. And now when you're downtown, you really can't see this deep space object, but when you're far away from the city lights, you might barely make out a faint little patch of light near Andromeda's waist. And this is actually the Andromeda Galaxy. This is the closest spiral galaxy to the Milky Way galaxy. It's sort of our sister galaxy. It's actually on a collision course with our galaxy. It'll crash into the Milky Way in about 4 billion years. We're not going to dive into too much detail with Andromeda. We actually look at her in greater depth during our fall seasonal star tour at the Planetarium. But I just wanted to point out that's one of the few deep space objects besides the Milky Way galaxy that you can see with the naked eye. Now I want to actually move our view to the south here. The Liberty Memorial is kind of in our way, so as usual, we will move our view a bit farther away to a more rural perspective. I mentioned the Milky Way, and summertime is the best time to look at the Milky Way. In the summer, we can see the galactic core, where it is densest and brightest. This is the densest region of the Milky Way, and we can always see it in the summertime here. So summertime is the best time to look for the Milky Way. If you want to try to spot the Milky Way, there is a constellation that can help you find it. And this constellation has a star pattern in it that kind of looks like a teapot. You might see a teapot around here. Here's the teapot's handle. Here's the lid and the spout. That teapot belongs to the constellation Sagittarius, the Centaur. And the teapot actually points towards the center of our galaxy. So if you can find this teapot in the southern horizon in the summer, you can more easily find the Milky Way. Also nearby Sagittarius is a fairly bright constellation prominent in our summer skies. That's Scorpius, the Scorpion. This bright red star is the heart of the Scorpion, and then its claws kind of go out here, sort of this fan of 4 stars. That's its claws. Then its body and tail curve downward with a stinger at the end. Now this sort of resembles a hook, and in fact Polynesian cultures saw this hook as representing the hook of their demigod Maui. And if any of you, the viewers have seen the movie Moana, that star pattern is actually prominent in that movie, as related to the hook of Maui. I wanted to mention that at the center of the Milky Way galaxy here is a supermassive black hole. We discussed that in our live star tour this season, but if you want to learn more about it, we actually did a live stream where we discussed this black hole, as well as some other mysteries of our universe. And that live stream we can post a link to. Again, it's featured on our YouTube channel, youtube.com/kcplanetarium. That was a fun show we did around Halloween a few years ago. So if you want to learn about other unsolved space mysteries, you can check that out. But we dive into more depth about the supermassive black hole at the center of our galaxy during that show. Over in the comments, we've got James saying howdy from Iceland. Oh my goodness, Jamie and Ruth, thank you so much for watching. I don't even know what time it is over there, but I appreciate you tuning in. Awesome. Great to hear from y'all. Got Jerry asking, will Polaris always be the North Star? Jerry, that is an excellent question. And the answer is no. So Polaris right now is the North Star because it's directly above the North Pole. And as the Earth rotates around its axis, the North Star remains stationary relative to everywhere else on Earth. But the North Pole will not always be pointing towards Polaris. Luckily, I've got a visual aid right here. This is an excellent question that I'd love to answer and demonstrate because the Earth rotates rapidly, similar to a toy top. And when you spin a toy top, it spins around rapidly, but it also slowly wobbles, rather. And so I can demonstrate that wobble. I'm just finding something to hold this top in. Here we go. Let me hold this up. I'll go back to this view. Any children watching? This is a DVD. We used to store data on these disk devices. That's the floppy disk of the current children's generation. So anyway, if we spin a toy top, it spins around to keep balance, but it will slowly wobble. And I spun my top really well, but let me do it a little bit worse so you can see the wobble a little better. There we go. So now you can see it wobbling sort of back and forth, right? In physics, we call that wobble precession. That's P-R-E, precession. And the Earth wobbles similarly. So I'm just pulling up a visual aid here so we can look at this. So as the Earth spins around, it also slowly wobbles, and it wobbles very slowly, once every 26,000 years or so. So in a few thousand years, the North Pole will have actually wobbled away from Polaris. And actually in about 14,000 years, the North Pole will be pointing towards a star called Vega, which we'll look at in just a moment. And so to future humans or sentient squids that have taken over the Earth in a couple thousand years, Vega will be the North Star in the future. So there you go. That was an excellent question, Jerry. Thanks so much for asking that. And let's jump back into our star tour. So Scorpius and Sagittarius are a couple of constellations visible right now. There's also the constellation Capricorn over here. And Capricorn always kind of reminds me of a Dorito, sort of like a big triangle. And then we've also got another constellation, Aquarius, which is starting to rise. It's a bit hard to spot because it's close to the horizon right now. I wanted to point these constellations out because they may seem familiar to some of you. These constellations belong to a famous group of constellations, and there are 12 constellations in this group. They are called the Zodiac. Now, I briefly discussed the Zodiac in previous live streams. We go into greater depth in the planetarium because it's a little bit easier to visualize on the planetarium screen. But during today's Star Tour, I wanted to kind of go in depth in a way I haven't done during my live streams yet. I wanted to explain why the Zodiac is special. Now, most people think of the Zodiac as relating to astrology. Astrology is not the same thing as astronomy. Astrology is more of a fun hobby for some people. There's no science to it, but some people try to use stars to predict things about people, like your future or your personality. Again, it's a fun hobby, but astronomy is a science, and astronomers focus on what we can observe and measure in space. But these constellations are related to astronomy in a way. And I'll highlight a few more of them. We've got Virgo and Libra over there, and there may be Pisces starting to rise over in the east. Now, if we look sort of from this perspective, you'll notice these constellations are all sort of lined up with each other. Now, it turns out these constellations all are lined up around the Earth's celestial sphere, along a line called the ecliptic. And actually prepared a little bit of a demonstration of how the ecliptic works. I've now switched over to some 3D planetarium software called Space Engine, and now we're looking at the Earth from space. Now the Earth is orbiting the Sun. If we rotate around here, we'll see the Sun in the background. And Space Engine can highlight the orbital paths of all the planets, including the Earth. Now, you'll notice here, if I zoom out, that all the planets orbit in sort of a flat disk, kind of like a big pancake, right, or a big frisbee. Now, that plane, that flat path, let me do it this way, there we go. That flat path is called the ecliptic. So that plane around which all the planets in our solar system orbit is called the ecliptic. Now let me remember how to spell Earth and return to it. Now, the sun is over there, right? And the Earth orbits the sun. It goes around the sun once every year, once every 365 days. But as the Earth goes around the sun, the stars behind the sun will change. And think about the angle between the Earth, the sun, and the stars behind it. If I fast forward time here, we'll start to see the sun moving. So if I've locked my relative position to the Earth, the sun will kind of be moving in front of the stars behind it. And we can even put the constellations up here, and we can see that as the Earth goes around the sun, from here on Earth, it looks like the sun is going around us. And this is why before we really understood the mechanics of our solar system and before we were sure that the Earth was not flat, that's why some people thought that it seemed like the Earth went around us, because from our perspective, it looked like it did. But just like when you're driving down the road and the trees are flying by your window, you know the trees aren't really moving. You're the one that's moving. Well, it's the same thing that's going on here. But it appears that the sun is moving in front of the background stars. Now, it's actually moving in front of the zodiac constellation. So you can see here, around September or October, the sun is moving in front of the constellation Virgo. We can speed it up even more and see that it'll eventually pass in front of Libra and Scorpius and Sagittarius and so on and so forth. There's another animation that can kind of help us visualize that as well. I've got it around here somewhere. There we go. So this is kind of a simpler visualization. So you can see the path between the Earth and the sun sort of projects the sun onto the background stars, and that is how the zodiac works. These 12 constellations happen to be lined up with the apparent path that we can see the sun traveling throughout the year. That's why they say the sun is in the house of your constellation on your birthday. The sun literally appears in front of one of these constellations, and whichever constellation it's in front of, that's meant to be your zodiac sign. Now, there's something interesting here that I bring up sometimes during my star tours. Oops. Here. If I reverse time, we'll see that the sun, at a certain point in the year, between November 29th and December 17th, it appears in front of this constellation here named Ophiuchus. So the sun actually passes in front of the 13th zodiac constellation. It's not considered one of the official zodiac constellations because, well, actually, we don't really know why Ophiuchus wasn't chosen, but essentially, the zodiac constellations were sort of an early calendar system that Babylonian astronomers used, and they essentially divided the sky into 12 equal parts that were sort of close to certain constellations, and they went with Scorpius instead of Ophiuchus for whatever reason. Maybe Scorpius sounded cooler, I don't know. Now, Ophiuchus here is a constellation that is visible right now. So if I come back to our night sky in Stellarium, and I clear out my screen here, there is that 13th zodiac constellation right between Sagittarius and Scorpius, and its name is Ophiuchus. Now, to the ancient Greeks, Ophiuchus represented the god Apollo, struggling with a huge snake that guarded the Oracle of Delphi. There were other myths that identified this character as Laocoon, the Trojan priest of Poseidon, who warned his fellow countrymen about the Trojan horse, and was later slain by a pair of sea serpents sent by the gods to punish him. Later on, Romans associated this figure with Asclepius, the healer, who learned the secret to immortality by observing one serpent bringing another serpent healing herbs. This iconic snake-entwined staff remains a modern symbol of healing and medicine to this day. So that's Ophiuchus for you. And Ophiuchus is going to pop up a little bit later when we get to our news updates. But for now, we're going to move it along and head over... sorry, one more thing. High in our sky tonight is the Summer Triangle, which is a group of 3 stars that form a bright triangle visible in our summer skies. And the brightest star in the Summer Triangle is this one here. It's called Vega. I mentioned Vega earlier as the future North Star. So Vega, Deneb, and Altair, those 3 stars form the Summer Triangle. And this pattern is a tool that some people used to track the changing seasons. When you start to see the summer triangle rising, you can tell that summer is approaching. But I just wanted to point it out because Vega was a star I mentioned earlier. But real quick, let's move on over to the eastern sky. We're going to be wrapping up our night sky tour in just a moment. I want to bring up my my PowerPoint again. One thing that we want to check out is to see if we can see any planets up in our night sky tonight. So I got this chart here that tells us the visibility of planets, and we can see that it looks like Mercury is visible at dusk. Mercury is very hard to spot though, so I usually don't feature it because you have to get very far away from light pollution to see it. Mars is also going to be barely visible right around sunset, although Mars is very far away, almost the farthest away it gets in its orbit from the Earth, so it's going to be hard to spot too. Jupiter will be visible in the early morning sky right now, as well as Uranus and Neptune if you have a telescope. But the planet that we will feature today is the planet that is up all night long right now, and that is Saturn. So let's jump back over to Stellarium and see if we can spot Saturn. It's rising in the east right now. Now, planets are a lot closer than distant stars, so when a planet's light reaches Earth, more of that light is able to penetrate the Earth's atmosphere, and our atmosphere is what causes stars to twinkle, because their light is so distant and faint. So a planet is going to be a point of light that does not twinkle. And that's a cat trying to get into our live stream. I'm not sure Bellamy wants to join today's stream, but maybe she does. We'll see. Anyway, so we're looking for a point of light that does not twinkle, and I think I spot one right over here in the southeast. That is Saturn in the constellation Aquarius right now. We can zoom in on Saturn here. We feature Saturn in much greater detail during our seasonal star tour right now, so if you want to learn more about Saturn and see it in 3D, and even fly through its rings and explore its moons, then come check out our live star tour, Sky Station Live. I do want to briefly shout out and remind everyone that Saturn did recently retake the throne as having the most known moons in our solar system. They announced 63 newly discovered moons back in the spring of this year, bringing Saturn's total moon count to a whopping 145. Actually, I think they added one, so it's 146 now. And we actually see all of those orbits in our star tour. So come check that out at the Planetarium if you haven't yet. Now, I'm going to fast forward a little bit here, a little bit later in the evening, because there's a very bright star near Saturn. It's almost as bright as Saturn itself, actually, and it's called Fomalhaut. Now, this is part of the Southern Fish constellation, but in Arabic, actually, Fomalhaut means the mouth of the fish. It's the 18th brightest star in the night sky, and it'll be near Saturn. And I wanted to bring this up as a little mini deep dive today because Fomalhaut is kind of an interesting star. Let's bring our PowerPoint back here. Now, this star has been discovered to be surrounded by several disks of debris. Sorry, just to go back, I forgot I had some charts showing the location of the planets. There's Saturn. And Jupiter in the early morning sky. But again, Saturn is near that bright star, Fomalhaut. And here is a photograph of this star taken by the Hubble Space Telescope. And this photograph actually contains a series of data entries dating from 2004 to 2012. And again, we can see this disk of debris surrounding this star. Actually, on November 13th, 2008, based on this data, astronomers announced that they had an extrasolar planet candidate orbiting just inside the outer ring of debris. So we can see that planet candidate there, a chunk of debris that was tracked over these dates. So astronomers started to think that this could be a protoplanetary disk, an infant solar system on its way to being born. This was actually the first extrasolar orbiting object candidate to be directly imaged in visible light, as captured by the Hubble Space Telescope. In May of this year, though, our new shiny telescope, the Webb telescope, took an even better and closer picture of this ring of debris, There you go. That's the ring of debris around the star. And actually, Webb revealed that there were 3 nested belts of debris. And it also discovered that these are actually asteroid belts. So these were the first asteroid belts ever discovered and directly imaged outside of our solar system. These 3 nested belts of asteroids extend out 14 billion miles from the star. That's 150 times the distance of the Earth to the Sun. Now, the observed asteroid belts were likely carved by the gravitational forces produced by unseen planets. So there are likely planets between these asteroid belts that are carving their shapes, similar to how in our solar system, the gas giant planets, Jupiter and Saturn, actually have carved out the shape of our and the layout of our solar system. The asteroid belt being between Mars and Jupiter, between the inner small rocky planets and the outer gas giant planets. So pretty amazing that we are studying this star, and we have been for a number of decades with old and new telescopes, and we can see these asteroid belts in distant star systems. Jerry's in the comments saying, I love learning about mythology too. Yeah, mythology is one of the best parts about looking at our night sky. We've done a couple live streams all about mythology, not just Western mythology, but mythology from other cultures. In fact, if you go to our YouTube channel, youtube.com/KCPlanetarium, I've got a curated playlist of all of our sky culture live streams. So I'd encourage you to check that out if you want to learn more about mythology, especially mythology from other cultures. Geraldine is chiming in the comments as well, saying good evening. Thanks for watching tonight, Geraldine. Let me know if you have any questions about tonight's show. Now, talking about the Webb telescope is a perfect segue for us to jump into our next segment, which is Webb Watch. So let's check out what Webb has been up to. And let's actually, I think I've already got this open somewhere. There it is. All right. So the James Webb Space Telescope has been up to a lot in the past few months, but the most exciting thing, I think, is that a little while ago, in celebration of the first anniversary of the Webb Space Telescope's activation last summer, NASA captured an unprecedented close-up of a cloud complex called Rho Ophiuchi inside the constellation Ophiuchus that we saw earlier. This is the closest star-forming region to Earth. And in this picture, this zoomable image, we can see some pretty amazing details. Now, this is the closest star-forming region to Earth, like I said. It's approximately 390 light years away from us, which allows for a highly detailed close-up with no foreground stars in the intervening space obstructing our view. Well, this is a pretty incredible image. I do want to compare, though, to our most recent image. So here is a comparison between the Spitzer imagery from just a few years ago. This was, I believe, captured around 2008, but you can see the amazing new technology and resolution we could see with the Webb Space Telescope. Now let's go back to our close-up here. Webb's image shows incredible detail and a lot going on. So it shows a region containing approximately 50 young stars, all of them in similar mass to the sun or smaller than our sun. The darkest areas are the densest, where thick dust cocoons still forming protostars. So inside these dark areas are stars that are on their way to being born, that they haven't quite ignited, so they haven't lit up these star-forming regions. But there are parts of this cloud that are lit up. There are huge bipolar jets of molecular hydrogen, which we can see here in red. They dominate the image, appearing horizontally across the upper third and vertically on the right. So these long streaks are hydrogen, big streaks of hydrogen clouds. They occur when a star first bursts through its natal envelope of cosmic dust, shooting out a pair of opposing jets into space like a newborn first stretching her arms out into the world. That's poetic. I did not write that. In contrast, there's another star a little bit lower. This star is called S1. It's carved out a glowing cave of dust in the lower half of the image. It's the only star in the image that is significantly more massive than our sun. Some stars in the image display telltale shadows also, indicating protoplanetary disks, potential future planetary systems in the making. So you can actually zoom in quite a lot on this image. In fact, we can post a link to that. Let me copy and paste that. You can post a link to... Oops, nope, that's not it. There we go. So if you want to zoom in on this image yourself, you're welcome to. It's pretty incredible, and there's just so much detail. I mean, look how far I've zoomed here. And so, again, we talked about protoplanetary disks in a little while ago around the star Fomalhaut, but we can see some of them, our astronomers have observed some of them inside this star-forming region. One of the Webb project scientists put it this way, quote, Webb's image of Rho Ophiuchi allows us to witness a very brief period in the stellar life cycle with new clarity. Our own sun experienced a phase like this not long ago, or this long ago, and now we have the technology to see the beginning of another star's story. By the way, the Webb team has already released a detailed look at all the planned observations scheduled for a year or two. We can post a link to that as well if you're curious about what they're going to be studying. But their plan includes deeper dives into the mysteries of our solar system, as well as looking at supermassive black holes, exoplanet formation, and even exploring the large-scale structure of our universe and diving far back in time to look at the origins of known space. So that's just 1 year of Webb, and we will continue Webb Watch for as long as we're doing these live streams, and of course posting all the other exciting updates on our Facebook page. So be sure to like and subscribe to us there. All right, we're going to take a brief pause here before we jump into more news stories from around the last few months in space and astronomy. So if anybody has any questions or comments, throw those in now. As an aside, kind of in the middle, there's one news topic I won't really be touching on, not in that great of detail, and that is the recent stories about UFOs, which have been popping up recently. Now, I do want to just throw out that the likelihood that there are little green men walking around is very low. In fact, we touched on this in that same Space Mysteries live stream I referenced earlier, where we talked about where are all the aliens, and there are a bunch of different theories, but essentially, if you think about the logic behind whether or not aliens would look like little green men, well, the truth is they probably wouldn't. An alien life form would be unrecognizable to us on Earth because it wouldn't have had the exact same 4 billion years of evolution that have led us to look like this. And the other problem is that space is really big and really old, and the likelihood of an alien passing by the Earth in the past 10,000 years, when humans have actually been recording our own history, is very unlikely when you think about the Earth's 4 billion year age. So it's much more likely that if aliens were around, they came to the Earth in the time of the dinosaurs, and they didn't see anything intelligent, so they just left. And the other thing is that if there is real evidence of UFOs and aliens, then it should be confirmed by science, not a single whistleblower testifying in front of politicians. So that's my little soapbox. Also, you know, we keep talking about crashed alien spacecraft, but I gotta say, if an alien spacecraft was so technologically advanced that it could traverse the vastness of space, and an alien could operate this vehicle to reach the Earth, then doesn't it not make much sense for that alien to just crash into the Earth, you know? Are aliens that bad of drivers? It doesn't seem like it if they can make it to the Earth. So anyway, that's my little soapbox about aliens. So I'm not going to be going into detail. Also, that is a developing story. So yeah, you'll just have to stay tuned on that one. So let's jump into a couple interesting news stories that have popped up recently. That's the rest of my PowerPoint. All right, so let's take a look at this. Now, this is pretty cool. This is from the European Space Agency. They conducted a controlled descent of a spacecraft. And they actually produced a little animation showing how this descent happened. Now, to back up a little bit, this spacecraft was called the Aeolus Earth Explorer, and it met its demise above Antarctica on July 28th at around 3 p.m. Eastern Time. Now, Aeolus was designed and operated by the European Space Agency, and it studied global wind patterns prior to its retirement, contributing to our understanding of Earth's atmosphere and enabling more accurate weather prediction. But the satellite had been losing altitude at a steady pace and was nearly out of fuel, and without intervention, it would have continued its uncontrolled descent and eventually burnt up in Earth's atmosphere, with debris falling unpredictably in potentially undesirable locations. So this animation here is going to show how they planned this controlled descent. So essentially, the reentry followed a series of complex maneuvers that lowered the defunct satellite's orbit from approximately 200 miles to a mere 75 miles, ensuring its safe return and eventual incineration in the atmosphere. So they used advanced physics models to predict the satellite's movement, and they actually controlled its descent by aiming it in certain ways to heat up certain components of the spacecraft to descend in a safe way and for it to burn up in a safe way too. Let's see if I can speed up the video here. So we can see the color is showing us parts of the spacecraft heating up. You can see its solar panels heated up first and other parts of it heated up. Oh, I guess this animation is pretty fast already. I'll slow it down. We'll go back a little bit. So the simulation is based on a model of the spacecraft that took the satellite's shape, size, mass, and materials into consideration, along with the principles of aerothermodynamics. And this demonstration showed that it is entirely possible to safely deorbit a satellite in a controlled way without the risk of debris hitting the ground. We can actually aim its debris or make sure that it totally burns up. So pretty cool, pretty fun. Kind of reminds me of a Kerbal Space Program in a way, which is a spaceship building program that I used a little while ago, actually, for one of my live streams. You can check that out on our YouTube channel as well. Let's check out our next news story. And oops, again. Here we go. All right, so there was a recent launch of a satellite that is actually part of a mission to attempt to produce medical drugs in orbit. So this is kind of just a wordy news article here. So I'm not going to read it verbatim, but essentially this spacecraft, which is part of a California-based startup who wants to manufacture products in space that can benefit from being created in the microgravity environment, and then deliver them back to Earth in a fast rate. And that company is called Varda. This capsule, this is the first capsule that was sent to space in an attempt to produce pharmaceutical drugs and return them to space. It's set to spend about 3 months in orbit and send around 90 to 130 pounds of finished products on a trajectory towards Earth. The microgravity environment provides some benefits that could make for better production in space, overall reducing gravity-induced defects. Also, protein crystals made in space form larger and more perfect than those created on Earth, according to NASA. So pretty cool that we're starting to manufacture products in space. And I did a live stream all about why we should be thankful for space and why it's important to continue space exploration. And this is a great example of one of those reasons. There are certain manufacturing processes that would be better in space, and especially related to medical science. The better we can produce, drugs and treatments, then the better it is for humanity. So if you want to learn more about why we should be thankful for space and why it's important to invest in space research and exploration, a live stream I did on a Thanksgiving a few years ago is a fun one to watch. Now, speaking of fun things, how would you like to be locked in a small room for an entire year for the sake of science? Well, you probably can't, because there is a recent mission that just began, and 4 volunteers began a year-long simulation for living on Mars. So in late June of this year, 4 researchers donned black jumpsuits and entered a red world where they will spend a year living and working in a simulated Martian environment. Here they are entering that habitat, saying goodbye to Netflix and cheeseburgers, although they may have those in the habitat, I don't know. Probably not. If it's Netflix, it'll be on a 15-minute delay, because that's how long it takes data to travel between Mars and Earth. This is NASA's CHAPIA habitat, which stands for Crew Health and Performance Exploration Analog. NASA and their acronyms. Love to see it. Again, in late June, they welcomed 4 volunteers to spend 378 days in an enclosed Mars-like world to help the space agency prepare for missions to the Red Planet. These 4 participants included a research scientist, structural engineer, emergency medicine physician, and a U.S. Navy microbiologist, who were selected from thousands of applicants. In fact, the call for volunteers was back in 2021. This habitat is a 3D printed environment, a 1,700 square foot habitat that's located at NASA's Johnson Space Center in Houston, Texas. It has a kitchen, two bathrooms, private bedrooms, a work area, as well as a recreational area for socializing. Inside this simulated Martian environment, the 4 volunteers will carry out different activities as though they were on a mission to Mars, including simulated spacewalks, robotic operations, habitat maintenance, personal hygiene, exercise, and crop growth. And this simulation will allow researchers and scientists to collect cognitive and physical performance data to give them more insight into the potential impacts of long-duration missions to Mars on crew health and performance. Ultimately, this information will help NASA make informed decisions to design and plan for a successful human mission to Mars, hopefully sometime in the near future. Jerry says, no UFO news? Fox Mulder is incredulous. I know, Jerry. It is unfortunate, but I'm not, you should know well that I'm not the type to sort of delve into hearsay and things like that. So it's fun to think about, but honestly, we don't need little green men to be excited about the universe, because there's a lot of amazing discoveries to be had out there. And in fact, there may be some life-related discoveries that could happen right here in our own solar system backyard, but they wouldn't be little green men, and we'll talk about some updates about that in just a bit. First, though, continuing our look at Mars, let's actually go to the real Mars and check in on a happy update, because we have reestablished contact with the Mars Ingenuity helicopter. This is after 63 days of somewhat agonizing silence, but now NASA's Martian chopper has finally phoned home. The Ingenuity helicopter reestablished communication with Mission Control on June 28th, officially logging its 52nd flight as a success, NASA recently announced. The space agency lost contact with Ingenuity as the helicopter was descending towards the surface of the red planet following one of its recent flights on April 26th. The reason behind this communication blackout, or the communication loss, is that there was a hill that was inconveniently positioned between Ingenuity and its rover pal Perseverance, preventing the Martian pair from communicating with one another. This was a known issue, and NASA did expect to lose communication for some time. Ingenuity does rely on Perseverance to deliver its messages to Earth using shiny antennas to exchange data at about 100 kilobits per second, blazing fast speeds. The data is routed from the Ingenuity-facing antenna to the rover's main computer before being transferred to Earth by way of an orbiting satellite. Since reestablishing contact, by the way, Ingenuity has completed 2 additional successful flights, so its mission is continuing without a hitch. We just couldn't talk to it for a couple months. Speaking of reestablishing contact, here's another happy update about a much older mission, and that is the Voyager 2 mission. And we have finally heard sort of a heartbeat from Voyager 2 after inadvertently losing contact. And we don't know the full details of this, but it sounds like just sort of an honest mistake. But essentially what happens is that about 3 weeks ago, NASA transmitted a potentially faulty command, which caused Voyager 2's antenna to point 2 degrees away from Earth. So somebody probably fat-fingered one of the numbers on their keyboard, unfortunately. You'd think they would double-check that, but c'est la vie. NASA's Voyager 2 spacecraft is about 12.4 billion miles away at the moment. It's on its way out of the solar system, having completed its primary mission studying the outer planets over 3 decades ago. NASA has continued communicating and operating the spacecraft, studying the interstellar medium at the edge of our solar system since its primary mission concluded. On August 1st, though, just about a week ago, NASA's Jet Propulsion Laboratory did announce that its Deep Space Network, DSN, snagged a carrier signal from Voyager 2, that heartbeat signal, and this confirmed that the 46-year-old spacecraft is still in good health, still operating, still has power. NASA's DSN consists of a worldwide large network of antennas and communication facilities that support interplanetary spacecraft, among other missions. The receipt of this heartbeat signal, as it's known, is a massive relief and a positive sign, but Voyager 2 is not quite yet out of the interstellar woods. The probe is still transmitting data, but those signals are now bypassing Earth and no longer being received. They're shooting straight past us. Consequently, the data being sent by the spacecraft is not reaching our deep space network, and it's also not receiving commands from ground controllers, unfortunately. Signals take approximately 18 and a half hours to reach Voyager 2 at its present distance. Mission controllers will now attempt to reorient Voyager 2's antenna such that it correctly points towards the Earth. But should these attempts fail, NASA will only have to wait until October 15th for an autonomous system reset, which the probe does several times every year, automatically to keep its antenna in the correct position. So the good news is that this problem should hopefully fix itself. But it is a lesson to future NASA engineers to double check those numbers that they've entered in their deep space spacecraft commands. All right, speaking of life, here's a fun update. We have not discovered aliens, but there is a research paper that has popped up that I wanted to highlight. And this paper confirms that Saturn's moon Enceladus is belching up a key ingredient for life. Enceladus is a tiny 300-mile wide moon orbiting Saturn, and it's very small. It's less wide than the United Kingdom, but Enceladus is one of the most interesting places in our solar system to scientists because of its composition. It has a thick sheet of water ice on its surface and a subsurface ocean of warm liquid water. So where there's water, we think there may be life. So Enceladus is a place we are very interested in, and it's a place we've been studying. Now this research paper, which was recently published in the science journal Nature, shows that scientists have found signs of a rare element that's crucial for life's existence being expelled from the moon's waters. Now, we already have known that Enceladus has geysers of water shooting out of its poles, thanks to the Cassini mission, which I'll talk about in a minute. Life as we know it needs water, of course, so signs of water are always a good sign and worthy of scientific investigation. But Enceladus is especially interesting because this new element I mentioned is called phosphorus. Now, phosphorus is not necessarily an organic element, but phosphorus is an important part of life nonetheless. Now, lost my place here. So phosphorus has actually turned up in old data from the Cassini mission, the Cassini spacecraft, whose mission ended in 2017. This spacecraft's mission lasted 20 years and it explored Saturn and its moons and system. Cassini observed Enceladus on its tour of the Saturn system and saw the moon erupting, spewing large plumes of water through cracks in its icy surface. You can actually learn more about Cassini's mission in our Saturn live stream special, which we did in July of 2020. We can post a link to that as well. Actually, the Webb Space Telescope imaged Saturn even this year and spotted more water plumes over 6,000 miles long, or more than 20 times the size of Enceladus itself, ejecting from the moon. There was, quote, water absolutely everywhere, end quote, one scientist who studied the plume said, and that water either stayed in the vicinity of Enceladus or fed Saturn's ring system. So this phosphorus detection is very intriguing because this element is the least abundant of those necessary for biological processes, according to NASA JPL, and it's a building block of DNA, the molecule that contains our genetic code. And it's the first time that this essential element has actually been discovered in any ocean beyond Earth. So this is pretty exciting. In fact, the concentrations of phosphorus were estimated to be 100 times that of Earth's oceans. So again, phosphorus does not prove that there's life, but we know phosphorus is an important element in for life here on Earth. So again, where there's water, where there's phosphorus, we're finding more and more evidence of things that contribute to life on Earth, so they may contribute to life in other places like Enceladus. And Judy's tuning in as well. Thanks for watching tonight, Judy, from El Dorado Springs. Hope you're enjoying tonight's show. All right. Just two more news topics to touch on. Let me make sure I've not accidentally skipped anything like I often do. All right, great. So we're going to be ending soon. So if you're still watching and have any questions or comments you want to throw in, be sure to bring those up soon because we're going to be wrapping things up after just a couple more news topics. So here's an interesting update from beyond our solar system out into deep space. And this is the recent announcement of a breakthrough gravitational wave finding, which suggests supermassive black holes are constantly warping space-time. Whoa, that's a mouthful. Crazy, right? Well, let me back up a little bit, all the way back to 1916. The beginning of the 20th century, cool and smart dude named Einstein predicted the existence of gravitational waves, and these would be changes to a gravitational field that travel at the speed of light. He predicted them based on his theories of relativity back then, but it wasn't until 99 years later, in 2015, that scientists for the first time actually detected those gravitational waves. And these waves are theorized to be caused by the merging of black holes or neutron stars. Now, the update is that on June 28th of this year, astronomers and astrophysicists at 5 different pulsar timing array collaborations announced data that strongly suggests the presence of a gravitational wave background, a constant murmur of low-frequency ripples in space-time that emanate from massive black hole mergers throughout the universe. Essentially, in 2015, we found evidence of gravitational waves caused by a single black hole merging. But today, we have confirmed that there are black holes merging throughout the universe almost constantly, causing sort of a constant background sort of vibration of these mergings, of these gravitational waves. So we now know that gravitational waves are everywhere, and they're constantly being churned out by black holes that are constantly merging. Now, these waves are thought to have been created over eons, millions of years, by supermassive black holes up to billions of times the mass of our sun, circling each other before they merge in spectacular fashion. The newly detected background ripples could help scientists better understand how gravitational waves are created and what happens to them as they propagate through the universe. They could also be used to study supermassive black hole mergers, events which can last for millions of years, and observing this gravitational wave background has important consequences for our understanding of the formation formation history of our universe, because supermassive black holes are the engines at the heart of galaxies. Jerry's in the comments saying, do you have any shows about black holes on YouTube? We for sure do. Probably the best one to look at would be our show about space mysteries, where we talk about the supermassive black hole at the center of our galaxy. One of the first shows I did also was about stellar evolution, where we talked a little bit about how stars die, and black holes are one of the ways that stars will explode and die. So a couple of options there for sure. We've got David, another one of our longtime watchers, watching from Colorado Springs, asking, is solid waste from the International Space Station returned to Earth by rocket or tossed out to burn up in the atmosphere? That is an interesting question, David, and we should find out. So it looks like most of the time, let's see. Yes, it turns out that most of the human waste, the solid human waste, is actually ejected from the International Space Station and burns up in the Earth's atmosphere. So there you go. That was a good question, and that makes sense really, because organic matter is for sure going to burn up on reentry. So there's no chance of a poop meteorite crashing into somebody's backyard. And also, it's really expensive to move any amount of mass to and from Earth orbit. So if we were to take anything back home, which we often do take solid like trash back home, then that costs money to bring that back to Earth, or bring anything up to Earth too. So anything organic that they can dispose of or even recycle, they want to do that. And for any liquid human waste, well, that is recycled. So if you're planning on going to space, just don't be afraid to drink some recycled pee. Great question, David. Thanks for asking that. And we're going to jump into our final news story, and this is kind of a fun one. Let's bring this up here. A prominent astrophysicist, who you may have heard of, named Brian May, co-authored a three-dimensional atlas of the near-Earth asteroid Bennu, an 85 million ton hunk of rock orbiting the sun. Oh, by the way, this astrophysicist Brian May does moonlight as lead guitarist of the rock band Queen. That's right, the lead guitarist of Queen is named Brian May, and he has a doctorate in astrophysics, something that a lot of people don't know. May co-authored this book with Dante Loretta, a planetary scientist at the University of Arizona and the principal investigator of NASA and the university's OSIRIS-REx mission, which we've talked about in the past. I'll tell a little bit more about it in just a moment. Brian May is also part of this mission team. The book is titled Bennu 3D, Anatomy of an Asteroid, and is being sold as the, quote, World's First Complete and Stereoscopic Atlas of an Asteroid. It's a 3D book. Now, Bennu is interesting because it was explored by OSIRIS-REx. OSIRIS-REx was a small spacecraft that arrived at the asteroid Bennu in 2018 and extracted a sample of the asteroid. We can see a photo of that sample being captured as this probe kind of crashed into the asteroid. Now, Bennu is a near-Earth object and a potentially hazardous asteroid, meaning that it has a non-zero chance of impacting the Earth. As such, Bennu is constantly being surveilled by NASA's Center for Near-Earth Object Studies. This asteroid is currently 51 million miles away from the Earth, and the odds of an impact are very low. 1 in 1,700 over the next 200 or 300 years, rather. So there's a very little chance, and we have a long time to worry about it. But NASA scientists still want to be prepared to defend the planet should such an asteroid take a worrying turn towards our planet. That was actually the point of NASA's recent DART mission, the Double Asteroid Redirection Test, back in September of last year, where NASA crashed a spacecraft into an asteroid and measurably altered its orbit. OSIRIS-REx left Bennu in April of 2021, and it's actually expected to return to Earth with samples this year on September 24th. So in just a month, we should be getting samples back from this mission. The retrieval of these asteroid samples will be a remarkable feat, and analysis of the rocky material arriving on Earth this September could clue scientists into the formation of asteroids, if not bigger questions like how our solar system formed about 4.5 billion years ago. Now, Brian May took a hiatus from studying physics at Imperial College of London to form the band Queen with Freddie Mercury and Roger Taylor. He actually still performs as Queen's lead guitarist. And he's credited with writing some of the band's biggest hits like We Will Rock You and I Want It All. And May actually returned to school in 2006 to complete his doctoral thesis on interplanetary dust. And you can actually read his thesis if you want. It's free and available online. And he defended his thesis in 2007. So if you want to read the doctoral thesis on astrophysics by Queen's lead guitarist, then you can certainly say he did that. So anyway, just a kind of a fun human interest story and a little fun fact about one of the most popular bands and a very prominent astrophysicist. So there you go, everyone. That does wrap up our news topics for today. So let's check into the comments, and we've got one more. Nope, that's just the comment from David asking about space poop. I hope I answered that question for you, David. So we are going to start wrapping up. So I'll just give another shout out to anyone still watching that we are currently counting down to our 100th show, and we do have a few fun shows that will be scheduled for the next few months. Again, next month will be our Create a Comet live stream, so mark your calendars. That'll be Friday, September 8th, where we will build a comet from materials that we're going to get from the grocery store, so that'll be a lot of fun. And again, I'll try to remember to post the ingredients to that before we do that live stream. October, we'll be doing another live stream about Hollywood astronomy and science fiction. November, we're going to do a special vacation live stream. Details to be released soon. And in February of next year, we are going to invite people to the planetarium and try out a live stream with other humans besides myself. So we'll see how that goes. It should be fun. We'll plan something fun for it for sure. And then we will celebrate our 4th anniversary in March of next year. And our 100th live stream, and that'll be the grand finale of our regular live streams. You will definitely see more of me, especially whenever there's an exciting event in the world of space exploration or astronomy. But for our monthly shows, those will be coming to an end. So I want to thank everybody for continuing to support our live streams. Lee, thanks for watching. Thank you for commenting. Rusty says, hey, Patrick, thanks for sharing information about human waste from space. Yummy drinking water indeed, Rusty. And Jerry says thanks as well. Thank you to everybody watching. Thank you to our longtime supporters and first-time watchers. Remember to go over to youtube.com/kcplanetarium to catch all of our past live streams, 95 of them now. And if you're watching on the Union Station Facebook page, head over to the Planetarium's Facebook page, facebook.com/kcplanetarium. I've been your Planetarium Manager, Patrick Hess. We are going to be wrapping up. Oh, Tammy's in the comments saying, why only 5 more? We're so sad about that. We'll enjoy every single last one. Absolutely, Tammy. Well, all good things come to an end, and I'd rather leave when people are going to miss me than overstay my welcome. Eric says, thanks. Great show. Thanks for watching. Appreciate you, Dad. And there's a screechy bird flying around who was maybe going to make a cameo, but I think she's kind of having a fit. So my mother, Lauren, says hi to Phoebe. Oh, is Phoebe gonna make it? Let's see. She's been kind of cooped up today. Unfortunately, that's my fault. Phoebe, come on, come here. Come here. Well, Bellamy's gonna come join us. Come here, Phoebe. Good bird. There she is, making a cameo appearance. Tweet. Phoebe, you want to give everybody a scratch? A scratch? How about a scratch? What about a kiss? You can come on camera if you want. No? Okay. Give me kisses. Give me kisses. Good bird. It's a good bird. Tweet. All right. Okay, say goodbye, Phoebe. Scratch. 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 So many scratch. Are you excited for our final 5 live streams? Yeah, 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 yeah. Ooh, big fluffy bird. All right, everyone. Thanks again for watching, y'all. Woo, a lot of tweets. Wow. Wow. We'll just let Phoebe play us off. Thanks, everybody. We'll see you next time. Yeah, yeah. Yeah. Yeah, 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 yeah. Scratch. Scratch. How about kisses? Good bird. That's a good bird. All right, everyone. Bye, y'all. Have a good night. We will see you next month for our Create a Comet live stream. Bye-bye.